And welcome back, everybody. I'm very excited to have you here joining us for another session of our Citizen Science webinar series. I'm really excited about today's speaker, and I think it's super timely considering Hurricane Erin moving up our coast right now to learn a little bit more about our weather and what's going on with our citizen science community. So today we're very fortunate to be joined by Melissa Griffin. Melissa is the Assistant State Climatologist at the South Carolina State Climatology Office. She received a degree in meteorology from Florida State University and worked for the Center of Ocean Atmospheric Prediction Studies and the Florida Climate Center for 15 years. She has also worked for a private STEM education company, published peer-reviewed research papers on climate impacts on the southeastern United States, and is involved in various weather-related outreach and education initiatives, including CoCoRaHS and the Community Collaborative Rain, Hail, and Snow Network. We're super excited and fortunate to have her here with us today. And with that, I'm going to turn it over to Melissa.
Thank you so much, Rebecca, for that wonderful introduction. My face might seem a little bit, different from the headshot that was provided in the seminar announcement, and that is our mascot for CoCoRaHS here in South Carolina, known as Wally the Water Drop. And it's just a fun way to be able to engage a little bit of our younger community in bringing them CoCoRaHS. So I'm going to go ahead and get started, but I am going to turn off my camera so that way you guys can pay closer attention to the slides. I'm looking forward to answering questions about CoCoRaHS. So we're going to talk about CoCoRaHS. So CoCoRaHS does stand for Community Collaborative Rain, Hail, and Snow Network, and that value of citizen science. But, before we can actually get into the program, we want to talk about why citizen science is important. Over the past few decades, more individuals who have been enthusiastic about some part of science, whether it's related to weather, if it's related to birding, beekeeping. There's been all these different initiatives to tap into the knowledge and enthusiasm that people have about the science and the environment around them. And it's been able to give us new perspectives on physical science. We may learn things from observers and people who have been out in the field for so long that we may not typically get in, sitting behind a computer just looking at data. We get to reach and talk to general public. I said, it's neat to engage with a variety of different individuals on that all have a common knowledge and a common interest. And that knowledge is sometimes really powerful because we get to learn different things by talking to people who have lived in certain areas and been impacted by certain events. We are able to make such huge strides in measuring precipitation, specifically with CoCoRaHS, and it helps in those areas where we may not have the resources to do larger projects, but again, we can count on our citizen scientists to help us out. And that help does come from helping, different government officials, local decision makers, and I'm going to show some examples of how that information has been kind of useful. So I just kind of want to start off by this beautiful image of looking at the Earth. Since we're going to be talking about CoCoRaHS, we're really going to be talking about observing and monitoring precipitation, and that's in the form of rain, hail, sleet, and snow, and that's all dependent on water. And so when we look at the Earth and we look at how much of the water actually exists, we took all of that beautiful ocean water, all of the surface water that's like available, and we took it and we just kind of put it into these spheres. So the largest sphere you see here is about 860 miles in diameter. That is all the water that is currently on the planet. And then if we take a look at this little smaller circle right here, sphere, that's about 170 miles in diameter, and that's going to be the fresh water. So out of, the larger sphere, this is what we have for our fresh water. There's a really tiny small sphere kind of here about the size of Atlanta. That is the fresh water that is available to us as the general public, as people for consumptive purposes. So it's really important for us to be able to track this type of weather data, especially when it comes to water. And through tracking the where it's raining and where it hasn't rained, it really does help us understand these impacts of the climate and weather and be able to make better decisions for response, and to plan into our horizon so that we can be ready for the next drought that comes or the next flood that comes. And the citizen science is not necessarily a new topic. Here, in the weather community, we have historically historical accounts that, and we can infer past climates from. This is actually a picture of a bookshelf I used to have in my old office. And as you can see, these particular books, they kind of date back to the late 1800s, and they contain a wealth of information. It's not just the numbers of the precipitation that's being monitored, but it's also the comments that these observers provide that give a little bit more knowledge into the potential impacts that we had with these particular events. So, kind of going from these ideas of keeping these historical accounts, I kind of want to give out a shout out to what I consider one of the first NOAA initiatives for citizen science, and that is the National Weather Service Cooperative Program. And it was formally established under the Organic Act in 1890. And the program's goal is to provide meteorological data to support National Weather Service and help monitor the nation's climate trends and variabilities. And while this may have been the start of, a systematic network of stations, taking this data across the United States, there were many stations that had begun operations long before that time. We've got records and accounts that were taken by um, let's see, just I'm trying to think of some of the earlier ones. It's going to be George Washington, Thomas Jefferson, Benjamin Franklin. They maintained weather records. Thomas Jefferson had almost an entire unbroken record of observations between 1776 and 1816. Before the National Weather Service Cooperative Network was established, U.S. Army forts began taking observations in 1820. And so we have this wealth of information that we can go back and we can look at and kind of see the trends and the patterns that we have had, not just in precipitation, but also in our temperature too. So just to kind of give you an idea of the expansive network we have. This right here is a image that shows all of those cooperative network stations, and of course that's across the CONUS US, Hawaii, Guam, Puerto Rico, Alaska. So you can kind of get an idea of just kind of how expansive this network is. But even when you look at this, you can kind of see there are some gaps in the network. I'm going to just take a quick look, a little bit of a closer look at the current state of those particular cooperative stations, and you can kind of see across the CONUS, there it is a dense network, and it does take a large amount of data. Every single day we've got these observers who are reporting daily temperatures of maximum minimum temperatures and precipitation. But there are still some areas where we could use some help in observing. That's where citizen scientists come in. And just to kind of also look at it, so we've got a couple of stations here within the United States that have received the Centennial Station designation by the World Meteorological Organization. So 16 of these particular co-op stations have been integrated into the global observing system. And in order to receive this designation, the station has to have been founded at least 100 years ago. It has to be still in operation today, and it has to have the data that's archived and available, meet certain standards, and also have a limited amount of missing data. So some of these stations have data back. I know the Charleston station has data back to the 1700s. The Blue Hill station that's located in Massachusetts has data back to the early 1800s. So we're fortunate enough to have these stations with these long period of records. Probably one of my favorite stations that has this long period of record is kind of from this Forts data that I had mentioned, where they started taking these observations in the late or in the early 1800s. This is a scan from a document that we had here at the Climate Center. It's now located in our state archives because of the unique and historic value of this particular document. So this was the journal of observations that was taken from the Charleston Board of Health, and it's from April 1861. So if there are any history buffs currently on the webinar, you might know that that was the first shots of the Civil War. So in addition to having very detailed penmanship of the temperature and the pressure and the precipitation, they also have comments in here where they talk about the rain most of the day, the bombardment of Sumter, a cloudless day, the surrender of Sumter, and then a bright and cloudless Sabbath, the evacuation of Sumter. So again, in addition to having those values, having this data is also really important. So I'm going to transition now, and I'm really going to spend the rest of this presentation talking about CoCoRaHS. So CoCoRaHS, again, is a community collaborative rain, hail, and snow network. The object of this, or the goal of this program, is to provide high-quality precipitation data through leveraging a grassroots community-based approach of a network. Precipitation is important and highly variable, and those data sources are few, and so rain gauges, sometimes even just a couple of miles apart, can have very differing amounts of precipitation in them. So it's kind of important to be able to measure precipitation with a very dense network. And this was the illustration of and the start of CoCoRaHS. So in July of 1997, there was a localized thunderstorm that dropped about 14 and a half inches of rain in the foothills of the mountains just out on the western side of Fort Collins, Colorado. Whereas at the National Weather Service Cooperative Station, they only measured, I think it was like right around like 2.5 to 3 inches of rain. The result was a devastating flood. Unfortunately, 5 fatalities. There were many people injured. I think they had like almost 200 water rescues, $200 million worth of damage to the Colorado State University campus, including, as you can see, all those waterlogged books. It was about 500,000 books that were destroyed from the campus library. And with knowing that the National Weather Service gauge had only so much data in it, it prompted members of the Colorado Climate Center, including Nolan Duskin, who is the father of CoCoRaHS, to go around Fort Collins and start conducting a bucket survey to actually determine how much rain had fallen so that they could do this analysis. So what they found as they were going through and they were doing the buckets is there was almost like an enthusiastic, like, I'd be happy to help. You can look at my buckets, you see where you can find standing water. And there was this enthusiasm to try and do better and to map better. So CoCoRaHS got started. So what I'm going to show you here right now is about the footprint of what actually started not as the Community Collaborative Rain, Hail, and Snow Network, but the Colorado Community Rain, Hail, and Snow Network. So this is an image from March of 2002, and you can see on the map most of the dots are centered in the northern portion of Colorado, between Denver and the Fort Collins area. And if I just kind of zoom out a little bit, take a shot from some of the more recent, one of the more recent rain events that we have, you can see those dots now extend across the CONUS, Hawaii, Puerto Rico, the Virgin Islands, Canada, and even into Alaska. As of today, we have over 25,000 observers that are helping take those measurements of precipitation and help fill in those gaps so that we have a better understanding of where it's rained, how much it's rained, and even where it hasn't rained. So it was kind of a little bit of a slow progress to get people on board first. So of course, Colorado was the early adopter, and they had a lot of their stations between 1998 when the program initially started, and then it's launched in 2000. And as a state climatologist, we would attend these conferences and we'd hear Colorado talking about this initiative that they were doing. And I'm pretty sure most of us were like, we want to do that in our own states. And so there was a flurry of activity from about 2004 up through 2010 as different states were coming on board, becoming CoCoRaHS states. And I know here in South Carolina, where I'm currently located, South Carolina came on board in 2008, and we actually have 75 observers that have been with the program since our start here in 2008. And that's not just something that happens here in South Carolina. We have observers that have been reporting since the beginning and have 25, almost 30 years worth of data that they have provided through the network. And, it's really our observers that make it so that it's easy for us to talk about how important having just one observation can be and the importance of one person can make a difference. So this is just kind of an example of a rainfall event that happened in May of 2008. There was an observer who recorded 7.2 inches in Comal County, Texas, and the nearby observers had less than that particular amount. And, so the National Weather Service saw this, CoCoRaHS saw this. We contacted the observer, talked to them for verification. There was a localized thunderstorm that just didn't move and it just dumped a bunch of rain. But had that observer not been there, that rain would not necessarily have been recorded. So having that one person can make a large difference. And our national coordinator, Henry Regis, took this image out of the airplane a few years ago, just to kind of give an illustration of how one person in one particular area can make a difference. As you can see, it's not raining everywhere, but that one little area where the rain is falling, that person who could be observing under that could definitely make a difference. So, I could go on and on. I mean, I could probably spend multiple seminars talking about how CoCoRaHS has made a difference, and how the data that our citizen scientists have recorded over the past few years have been instrumental in helping us understand the significance of certain events. I'm going to just talk about a few of the events that happened in 2024. This is not an all-encompassing, we're going to break down every single event that happened, but some of the more impactful events. So we're going to just kind of start off by taking a look at precipitation as a whole for 2024. This particular map is provided by NOAA's National Center for Environmental Information, and it ranks the precipitation for that particular, for 2024, against the year, the rest of the data that's available. Most states go back to 1895. So any of the maps that you see where you see the lighter green states, that's going to mean that the 2024 ranked in the top third wettest years since 1895. And the darker the green means it's in the top 10. We don't have a particular state that was the wettest year on record. And then where you see those drier or those browner colors, those are going to be states that were in the bottom third for rainfall, or the third, within that rank of dryness. So when you take a look at this over, a year, you just go, okay, well, California was wet, Montana was dry. It looks like the East Coast was pretty wet. Louisiana sticks out there as also being in the top 10 wettest. But when we look at this data on an individual event base, there are a lot of highs and lows that we go throughout the year before we get to this point where we're able to take a look at the data. Louisiana started off the year with a significant drought and still ended up making it into the top 10 wettest years. So again, having that data is really important when we're making these types of assessments. So let's just start in January and talk a little bit about a Northwest winter snow event that happened about mid-January. So this particular event was pretty significant because of the amount of rain precipitation that was observed across portions of southern Oregon coast and the northern California coast. So anywhere where you see the bright red colors is going to be about 3.5 to 10 inches of rain that fell in these particular areas. And one of the things that goes along that our observers are able to do is putting comments when they make a report. So I know personally, I look at the data, but then I also love to read the reports and the comments that come from our particular observers. So this particular observer actually talked about, that the soils have been really saturated from even previous rains, and it just made the runoff and made more runoff and widespread ponding. Creeks were at record highs, roads were flooded. But one of the things they also do is they kind of break it down and they tell you, like, between different time periods, how much rain actually fell. So they were going out and checking their rain gauge, not just once a day, but multiple times throughout the day. And this information is really vital when we're looking at, especially from like a National Weather Service perspective, how much rain fell in a certain time period could be critical for, issuing any type of like flash flood warning, and doing those verifications too. So this was the precip side of it, but in the mountains, so the mountains that we see, you can see this is actually looking at accumulated snowfall over that same time period. So while there was precipitation and rainfall, heavy rainfall on the coast, some of the higher elevations of the mountain, actually got up into 30 inches over this period. So I'm going to take this look at this one right here in Steamboat Springs, Colorado, and this is an interesting report because in addition to reporting their snow depth on this particular day, that was another 13 inches, so making their snow depth 33 inches over this 3 days. But they also talked about the high winds blowing the snow around, so they weren't really accurate about how, not sure how accurate that particular snow depth measurement was. So that's just kind of an example. But as this storm system moved across the U.S., it moved into portions of the portions of the CONUS that don't necessarily deal with snow that often. It does snow in Tennessee, it does snow in Kentucky, but maybe not to this amount. And there were reports of 7 inches to almost a foot of snow in portions of Tennessee. So we've got one here right outside of Davidson County, or in Davidson County near Nashville, where they actually not only took the snowpack depth and the new snowfall measurement over this particular period, which is the 14th through the 16th of January, but they also did something known as snow water equivalent, where they melted down the snow to actually see how much water content was in that snow. And so, they kind of give a little bit, they took a new snow measurement and they made sure that they were using their snowboard in order to do that. And then we had another observer, and I'm not going to point them out or put their, their station number up here, and said, I'm new to measuring snow, so I'm learning from my mistakes. And so having, again, even saying I spilled some, or I'm not 100% sure what I'm doing, really does help us be able to take a look at that data, and then also reach out to the observers and answer questions and help them get the training that they may need so they feel more confident the next time there's snow in the South. So in addition to rainfall and snow, one of the other aspects of CoCoRaHS is measuring hail. So in mid-March of last year, there was a pretty significant severe weather outbreak. And typically we don't see this many hail dots on the map. There are not very many people who measure hail. It's a little bit harder, and it's not necessarily a requirement to be an observer in CoCoRaHS that you measure hail. But the one that really kind of stuck out to me was this red dot here in Oklahoma City. And in the area of Oklahoma City, these are just some pictures from social media. People were taking the hail cores, they were cutting them in half so you could see the concentric circles and putting them next to other objects so you could kind of get an idea of about how big the hailstones actually were. This particular observer in Oklahoma actually took very detailed accounts of the hail, everything from the largest size that they found, the smallest size, what the consistency was, how long that it actually hailed. And so this particular information is extremely important because we do not have a fully flushed out database on hail. And so CoCoRaHS and our observers have been very instrumental in helping build that hail database for future analysis. It may not necessarily have been a weather event, but the solar eclipse happened in April, mid-April. I was fortunate enough to get to experience totality in 2017 when I lived in Kentucky. And it was neat to kind of go the next day, so on April 9th, and actually look at comments from our observers and see what they had to say about the eclipse. So this particular observer in Missouri talked about, cloud, there was fog and thunderstorms early, but it looked like they had cleared out and they were actually able to see the solar eclipse. And then there's another one here from Indiana who talked about no rain in the last 24 hours, kind of gave us some sky conditions and everything. And then, yeah, yesterday's eclipse was amazing. Wowie, wow, wow. And then this one in New York went a little bit deeper into it and actually talked about, not only the solar eclipse and how it was profound, but also talked about how temperatures dropped 3 degrees at their location during the solar eclipse. So again, maybe not necessarily tied directly to precipitation, but some really interesting information that can come out of the comments that our observers provide. In addition to, so we've done hail, we've talked about rain, we've talked about snow. We can also have measurements of evapotranspiration. So evapotranspiration is water that is evaporated from the ground back to the atmosphere, both as transpiration from like leaves and plants, but also direct evaporation from like open water and even soil. So these are a little bit fewer and far between with our observers. We don't have a lot of them that do the evaporation, but they really do do come in handy when we are looking at heat waves and a lack of precipitation in certain areas. And so this particular observer in Alabama was reporting actually there's two observers in Alabama that were reporting their evaporation over this 3-day period when we had an intense heat wave at the end of June. And even the observer, an observer nearby said it's been over 2 weeks without rains. The temperatures have been in the 90s every day. It's getting dry quick. The ponds are depleting, and that's with or without livestock drinking. So the other side of precipitation, in addition to measuring, large amounts of precipitation, is also measuring the lack of precipitation, and potential how that can lead to potential drought and even flash drought examples, which I have a couple of those coming up. So then we get into tropical season. So I have a bunch of different tropical events where CoCoRaHS really kind of came in instrumental, our observers, in helping make those observations. So Hurricane Beryl came through the Houston area, and you can kind of see almost the track that the storm took with that line that extends from Texas through Arkansas, Missouri, into Illinois, Indiana, and Michigan, as with the amount of rainfall that fell. So anything that you see that's kind of a yellow dot or higher is going to be at least 3.5 more or inches during this particular time period, July 6th to the 11th. Our maximum CoCoRaHS total, so from an observer in the Houston area, was 14.10. The maximum amount for this particular storm was just shy of 15 inches. It was taken from a observation or an NWS co-op in Thompson, Texas, and it was 14.99 inches. So I went and looked at this particular observer with their totals, and in their notes, they didn't have much to say, but in their notes, they actually broke down the time periods in which they observed the precipitation. And again, knowing that can be very vital when it comes to looking at, for National Weather Service, do you need to issue watches or warnings when it comes to flood? One of the other things that kind of caught my eye on this one was these clusters of red dots up in the Vermont area. And so I went and took a look at it. And there's a station that in Vermont that reported 7.11 inches over that time period. And I went and clicked on it, and thankfully enough, they actually had some comments in here. But the thing that caught me was, I'm glad the 1-year anniversary celebration Mother Nature threw to remind us of the devastating July 10th, 2023 storm is over. And so I dug around, and I actually found from the National Weather Service in Burlington this side-by-side comparison of almost to the day the record floods that occurred in 2023, and some of those observations that you see there in the purple are over 7 inches, and also CoCoRaHS observers who made those particular observations during that event. And then on the left is going to be the storm totals from the remnants of Beryl just a year from the previous event. So again, that was kind of an interesting thing as I was digging through and preparing for this presentation to find out. I mentioned drought monitoring. So the U.S. Drought Monitor, it focuses on these broad scales of conditions. They try and help, these different designations helped us to determine potential impacts and severity of drought in different locations. So earlier in the presentation, I talked about there being some pretty heavy precipitation in portions of the Pacific Northwest and in California. Well, that particular precipitation helped lead to the development of undergrowth in the forest. And when we got into this situation by July, where we're actually seeing a lot of drought conditions across portions of Oregon, Washington, Idaho, Montana, and even into portions of New Mexico, we started to have some significant fire activity in that particular area. One of the things that CoCoRaHS also has is what we call condition monitoring, and this is something that our observers are allowed to, to put in weekly reports of the conditions at their particular location. This is another set of data that is really important when we have these observers who consistently report what's going on in their backyard. It helps us as we make recommendations to the U.S. Drought Monitor or even our own state drought plans. What have conditions actually been back on the ground, so we can take that slider and go back in time and actually see what the observer has said about these particular conditions. So this particular observer in Oregon said had 90 degrees or higher temperatures for over 2 weeks, which I've never seen in my almost 50 years of observing weather here. They also talk about fires burning in the area, it being very smoky, and their own vegetable garden unfortunately had succumbed to the heat. We have another observer here in Washington that talked about over the last month since my last report on June the 26th, we've only had 1/100th of an inch of rain, and that was attributed, and they knew exactly what day it was. And then they talk about the large fires, they talk about the heat, and they talk about irrigation outages. So having all of this information is just from our observers is vital when it comes to the monitoring these drought conditions and even wet conditions too. So going from the West Coast back to the East Coast in August, we had Hurricane Debby make landfall in Florida, and then it made a secondary landfall along the South Carolina coast as a tropical storm. The maximum amount of rainfall that was observed in Debby during this time period, August 4th to the 10th, was 22.02 inches of rain, and that was in Monk's Corner, which is here in South Carolina. And that particular observer, I reached out to them because I was like, just wanted to, verify everything was okay with them. That's a lot of rain, even for the East Coast, and talk to this observer. And that total, that 22.02 inches of rain, is the second highest amount of rain that we have received from a tropical system. So that's going to be either a depression, a storm, or a hurricane on record here in South Carolina since 1950. So that's a pretty impressive total for us to actually have. And so again, they actually kind of, for that particular day with the heaviest rain, almost 10 inches in one day, kind of gave us an idea of what that fell in between, or the time frame that fell in. So unfortunately, after Debby moved through, we started to deal with drought conditions here in the Southeast. And each one of those little diamonds that you see that points down and is either an orange, red, or dark red kind of shows the drier conditions. And then the gray are going to be the near normal. And then the triangles that point up that are the blue, that's going to be kind of the wetter than normal conditions. So this particular location here in North Carolina was actually talking about since August, the 1st of August, we've had 6 inches of rain. And this is nearly 2 times as much rain that we've had for, an entire month of August. So they talk about some of the localized flooding that was going on in that area. But as you can see, it's kind of also surrounded by, there may have been wet conditions that were lingering from Debby's passage as it moved through the Carolinas and then up the East Coast. But we also see a lot more of these like darker triangles with the drought. And so just a quick look at that drought monitor. Again, you can see, especially in Alabama, and even parts of Tennessee, how severe that drought was. Just kind of looking again at those drought monitors and, kind of looking at reports, this particular location in Tennessee said we finished the month of August with 0.07 inches of rain. And then they talk about the ponds and the springs that were drying up, cracked ground, and that the pastures were pretty much non-existent. So again, just kind of demonstrating the power that citizen science observers and the comments and the observations they make, that it can be really important. Just have a few more slides to kind of show you. I would be remiss not to talk about Helene at the end of September in 2024. So the maximum rainfall that was observed during Helene was 30.78 inches of rain, and that was in Busick, North Carolina. So this particular event caused heavy rain across portions of northern Georgia, the upstate of South Carolina, and western North Carolina. I'll zoom in a little bit so you can see some of these totals. So basically anything with a red dot is over 14 inches of rain, and you can see how widespread just over 14 inches of rain is. If you look at anything that includes like an orange dot, that's 10.5 inches of rain or more. So very widespread event in a mountainous area that caused devastating flooding. And there were observers that were there that were actually reporting during this time period. So one of the observers in Hendersonville reported on the 26th that it was all related. The initial rain was related to an event that had happened, or a precursor event that had happened to this particular tropical system. And then we had an observer in Black Mountain that talked about their home, unfortunately, was destroyed by falling trees, and they had to evacuate to the Charlotte area. Another one in Banner Elk, our rain gauge was swept away in the storm. And the last count that we had, and we knew that was in the rain gauge, was about 8.5 inches. And then we go into October, and Hurricane Milton made landfall on the west coast of Florida, producing 20.40 inches of rain. That was taken by a CoCoRaHS observer in the St. Petersburg area. And, we had an observer just in Pinellas County, Florida, that said, I'm not really sure about the accuracy of what I've got. They noticed that the top had blown off of their rain gauge, and they're pretty sure some of it had actually spilled out of the main tube, and mentioned it's too bad to go outside. That's one of the things that we really do stress with the observers, is that if the conditions are dangerous, we don't want you to go check your rain gauge. We want you to be safe. We appreciate that once conditions are clear and safe to go outside, that you can take those observations and provide them to us, but we never want an observer to be in harm's way. So I just kind of want to close with showing a couple of the observers I've had the privilege to meet here in South Carolina. It is truly a community of people who are enthusiastic about a project, enthusiastic about providing this data, that really make CoCoRaHS so successful. And I've got observers from all different ages, walks of life. We've even got a second grade class at one of our local schools here, that they take the rainfall measurements during the school session and provide those to us. So real quick, just a couple of frequently asked questions. Who can join? Hopefully by this point, you realize anyone and everyone. This program is definitely made up of people who are enthusiastic about weather, and they could be 4 years old or 104 years old and come from various backgrounds. Is this data useful? I hope through the different, scenarios that I showed, the different events that we had in 2024, that you will understand how important the data is and the different entities that use that data. And then, of course, one of the more frequently asked questions is, how do I become an observer? And there really are just 4 easy steps. So the first is going to be register online. You can go to CoCoRaHS.org. There is a variety of online training slideshows. There's PDFs, there's videos. So CoCoRaHS has really done a fantastic job of providing training materials through different media to help the observers better understand how to make their observations, how to site their stations. And then, of course, there's always a chance to reach a local coordinator, whether it's a state coordinator or even, CoCoRaHS headquarters. They're an amazing team, and they're able to help. Acquire a rain gauge. We do all use the same rain gauge, and then just record and report those observations. The ability to put in those observations, you can do it on a computer. CoCoRaHS also has an app, so you can do it as you're heading, out for your day. You can open up your app, check your rain gauge, put in the data, hop in the car, and drive to work. It doesn't take very long to enter in that data. And so I appreciate Rebecca and the team at NOAA Education for giving me this fantastic opportunity to talk about CoCoRaHS.
This is Lisa again from NOAA Library, and we have some time to answer your questions, audience. So please type them in the Q&A chat, and I will upload them for Melissa. And so let's give it a second. Thank you. That was really interesting, and I'm so intrigued by the wonderful comments historically. I mean, now I have to wonder how people will think about our comments from now about our own weather in the future.
Yeah, the comments from our observer, I mean, the qualitative, the quantitative data that we get, the individual observations of the rainfall, the snow, the hail, they are fantastic, and they really do help us do, post analysis on events and even research. I mean, CoCoRaHS data has been used in a research setting and in research papers. Those comments are really just, to me, they have an impact too. I had somebody ask me, do you actually read the comments? And I'm like, I read the comments every morning when I come in for South Carolina. I've learned what a frog strangler is through reading the comments, which apparently is a heavy rain event. And I've been able to engage with some of the observers because of comments that they made. We had an observer here I think it was sometime last year, who in their comments said, I think a tornado went through my backyard. And so I reached out to that particular observer, and I was like, can you send me some pictures? And he sent me pictures, and I forwarded them on to the local National Weather Service for him, and they went out, and sure enough, he had a small tornado that went through his backyard. So those comments can be really helpful when it comes to not only looking at like the impacts of a particular event, but you never know what you're going to find in those comments.
Absolutely. We did get a question. Let me put that on the screen.
Okay.
This question asks, I realize CoCoRaHS relies on the use of the standard rain gauge. However, has there been any consideration to allowing readings from those who use automated rain gauges?
That is a really good question. So CoCoRaHS does, we do ask that all of our observers use the same rain gauge. So that rain gauge was kind of in that picture at an end. It's a 4-inch plastic rain gauge. It's available through a couple of different vendors that you can actually, there's links on the CoCoRaHS website to get. And right now it's running about $40 to $45 depending on the vendor. And we like to have everyone on using the same rain gauge, because then we know we have a standardized network of instruments that we can then do comparisons for. With it coming in at about $45, it's a little less cost prohibited for certain individuals. There are a variety of automated stations out there that range from like the $200-300 range all the way up to the $1,500 range. I'll speak for my mom. She is a CoCoRaHS observer, and she also has a Davis Instrument automated gauge. So she uses her CoCoRaHS gauge to do her actual manual observation. And what she has gotten in the habit of doing is then also including the rainfall catch from her automated gauge in the comments section. And sometimes, she puts a little bit more information in there about, like, she thinks it may have undercatched because it was a really heavy rain event. She saw rain spilling out of the top of it. But the idea is to try and get everyone to be able to use the same instrumentation, because then we know we can do those comparisons.
That makes sense. I just wanted to read a comment that came in through our chat. It says, no questions, but I work for the Radar Operations Center, and we use CoCoRaHS regularly to check the performance of the NexRad. We appreciate this data. Plus, I am a CoCoRaHS observer in Oklahoma.
Thank you so much for being on. I'm hoping there are a couple of CoCoRaHS observers that are on, and I know those of us who are in the in the field, whether it's National Weather Service, NOAA, emergency managers, we know how that data is getting used, and I'm hoping that there are some CoCoRaHS observers that now understand that they do make a difference. Those reports are so important to so many different people. Whether knowing it rained 5 inches yesterday afternoon or it hasn't rained in 5 days. Both ends of the reporting, the zeros. We like to say zero, be a hero, put in a zero. So that way we do know if it hasn't rained in certain areas. So, there's so many different uses for this data, and we could not track some of these events and understand the impacts of them if we didn't have our CoCoRaHS observers.
This next question is from Ben, who asks, is there a specific time that you prefer observers to report in?
That is a great question. Thank you, Ben, for that question. We typically like our observers to report between 6 and 9 a.m., and that coincides with when our National Weather Service co-op stations also make their reports. So that way we have a really nice, dense network of 24-hour precipitation that ends roughly around the same time. I understand that sometimes, people have to leave very early in the morning. I have an observer here in South Carolina who reports at 3 o'clock every morning. I also have an observer that reports at 5:30 in the afternoon. So that data is still collected and it still can be used. But when it comes to actually doing those comparisons with the NOAA products, we typically like to have our observers report between 6 and 9 a.m.
Excellent. Before I flash the next question across the screen, I just wanted to mention Chris has a chat comment, and he says, great idea with placing Davis tipping bucket amount in the daily CoCoRaHS comment.
So I'll let my mom know you said that, Chris.
All right. This next question is anonymous and asks, does CoCoRaHS inspect sites? I'm unofficial at present, but I've been using the cylinder for a few years now.
So that's going to be dependent on the capacity of the either state coordinator or local coordinators. For me, I help at the state level, bringing in recruitment. Sometimes I will go out and help site a gauge, especially with some of the school districts recently trying to find unique ways for them to put a gauge on their property. Our National Weather Service partners, usually there's a CoCoRaHS coordinator at the NWS offices. They have been able to help in the past. Sometimes they don't have capacity to do that. We also have some of our CoCoRaHS champions, and those are going to be our coordinators that are kind of at the county level, and they're willing to go out and help do inspections, to help clean a gauge, take someone, spare parts if we have some available. But we don't necessarily do like a mandatory site inspection.
Rebecca, our coordinator, put a comment in the chat that says CoCoRaHS is also a great program for schools and libraries to incorporate citizen and community science, and I can't agree enough.
So that is one of the neat things about CoCoRaHS. So over the nearly 30 years that CoCoRaHS has been around, they have collaborated with different educators across the United States and have developed curriculum and educational videos that tie in with observing the data. So there are some lesson plans that were done in conjunction with 4-H that are available. I know I have a couple of different lesson plans that I've helped develop for CoCoRaHS here in South Carolina. So it is a really good way. It does align with standards. So there's weather and climate standards usually in elementary school. Sometimes in middle school, they go back to those particular standards. So it's a fun way to get the students involved. They're able to take the data and then they can use that data in the classroom. I have a teacher here who they take the data from the science teacher, from the observations, and give it to the math teacher, and then the math teacher actually uses real live data that they've collected for some of the lessons in the math classroom.
I love that. For our live audience, there's a link to lesson plans in the chat. And for those of you who are listening to the recording, please go to the CoCoRaHS.org website to access those lesson plans. We do have another question. Let me flash that across the screen. This question is from James Lewis, who asks, does CoCoRaHS publish a summary of precipitation extremes by state on an annual or historic basis? I'm in a NOAA office, and we're always looking for more climatological data.
So thanks, James. There's been some work done recently by Russ Schumacher, who's the state climatologist of Colorado at the Colorado Climate Center, where CoCoRaHS is housed, on looking at extreme precipitation and having some of that data available. I know he's been looking at data from the 100-year event or the 1% chance event of happening. We have some seminars that CoCoRaHS actually does, and I believe there was one on 2024 that kind of did an overview of some of the more impactful events where we had some of that like historical perspective in the data, and then also current. Personally, here in South Carolina, I use CoCoRaHS data weekly. I do a weekly weather report. I always have CoCoRaHS data in it, and I do a end of the year summary where I also look at the CoCoRaHS data. Now, CoCoRaHS data is being archived at the National Centers for Environmental Information, so that data is available there, but it's also publicly accessible at the CoCoRaHS site. So you can go to CoCoRaHS.org, click on the map, click on a dot, and you can actually access the data. There are a couple of different data viewers that CoCoRaHS has developed over the years that allow for ease to look at the data. You can look at it in a tabular format. You can actually look at it through widgets and everything.
That's great. That's a great tip. It looks like there was another question in our chat that says, can you get CoCoRaHS data into XMACIS?
So actually, CoCoRaHS data is available in XMACIS. I believe that a station has to have been recording for at least, I think it's a year. It might be a little more than that before that data actually becomes part of the XMACIS ingest. So I know that CoCoRaHS data that we have are long-term CoCoRaHS stations that have been ingested by NCEI and are available at that archive, but you can always go to CoCoRaHS.org to even access a station that may have only reported a couple of times in a year. You can still get that data there. We try and keep the stations that have been reporting and have been really good reporters keep that data and make sure that it is getting into the archive. So you should be able to get some of that data from XMACIS. So hopefully, if you have any problems, you can have my contact information. We should be able to get a hold of it.
Lisa followed up with another question: will there be any more annual conventions in Colorado?
You know, that we get that question so much. People want to get together, they want to do meet and greets, and it's fantastic because of this community. We've toyed with in the past of doing some annual, get-togethers and trying to have a big CoCoRaHS convention. I don't know if Henry is on this or is going to watch this at some point, but maybe we can readdress that. I do know that there have been some of the National Weather Service offices, some of the state coordinators over the years that have had meet and greets. Sometimes they usually happen around football games. You get a bunch of people together and say, "Hey, we're going to have a CoCoRaHS meet and greet in the parking lot as we're tailgating for X football game." Some centers have opened up and had like co-op and Skywarn and CoCoRaHS appreciation days where people from the local CWA have been able to come and meet other CoCoRaHS observers, other co-op observers, and the Skywarn community. I mean, most of those kind of come together because everybody has that same interest. But no, I can't think of any big conventions in at this time.
Sounds like a good time, actually. Librarians will join. It looks like there's no more questions. We'll give it a second in case they come through. We did get 2 comments. There were actually links to ACES sites. One was to xmaces.rcc-aces.org, and another one was scaces.rcc-aces.org for those who want to follow up with those links. We just got another question from Norm, who asks, I wrote some Python code about a year or so ago to pull CoCoRaHS data for selected stations in my area, but it'd be really nice to have an API implemented on the website to make that retrieval easier.
I can tell you that is something that we have discussed internally amongst like the CoCoRaHS team. So we usually, as coordinators, get together once a year to try and talk about what are some of the needs that still need to be met. How can we improve things for CoCoRaHS? And I know that having that API, that open API, is something that has been discussed. I can tell you we'll put a pin in it for stay tuned because it is something that we have been discussing. And hopefully, if we can get the funding to get it implemented, we hopefully will have that be able to roll out, in the next couple of years.
Excellent. Well, it looks like that's all our questions. What a great conversation. I appreciate all the good interest by their audience. I'm going to go ahead and thank you so much, Melissa. It's been wonderful having you here today. Um, and also, thank you, Rebecca, for organizing this fantastic event. Rebecca, do you have any last comments?
Absolutely. Again, wanted to repeat, thank you so much, Melissa. I really appreciate you taking the time to share your wealth of information with us. It was incredible. Our Citizen Science webinar series is held every month. For those of you who this might be your first webinar, or if you get the fortunate experience of seeing me every month, we host these webinars every month. And during the fall, we're going to be focusing on AI and the role it can play with citizen science, as well as some of the work that we do here at NOAA. Our next webinar is going to be on September 17th. We're going to be working with the folks from Rip Finder, which is a new app technology that is using AI and citizen science to track rip currents along the coast and issue public safety announcements about it. So we're really excited to see the innovation coming in that field. Again, that'll be September 17th, and we'll be sharing the details with that shortly. That's all for
Wonderful.
me.
Wonderful. Thank you so much. This is a wonderful series. And audience, we hope to see you at the next Citizen Science seminar. So thank you for attending and enjoy the rest of your day. Take care.